This is how to do a paired samples t-test in SPSS. We're going to use a very similar setup as we did for our previous example with the independent measures t-test. Mickey is a dog trainer studying reinforcement effectiveness. He gets 16 puppies from 8 litters with 2 puppies from each litter. He matches each puppy in clicker training with its litter mate in food reward training. After the training, he measures the number of correct responses by each puppy in 10 exercises. Was there a difference between the two training techniques? So notice that the setup on this is slightly different. Rather than randomly assigning 16 puppies to 2 groups, he selected 8 litter mates, twins if you will, and assigned 1 twin to each of the 2 groups. Well, let's walk through our 5 steps. First of all, the appropriate statistic is the paired sample t-test, because we have 2 groups that have been deliberately matched. The null and alternative hypothesis. Well, like the independent samples t-test, our null is going to be that the mean of the population from which the first sample was drawn is the same as the mean of the population from which the second sample was drawn, or mu1 equals mu2. However, there is another way of writing the null hypothesis when using a paired sample t-test, and that is mu sub d equals 0, or the mean difference equals 0. The alternative hypothesis, that depends on how you set up the null. In the first case, we could use mu1 does not equal mu2. Or we could say mu sub d does not equal 0. In both of these cases, we're using a non-directional test because we're not suggesting the direction of change or which type of training will be superior. Selecting a level of significance, we are going to use a two-tailed test, again, non-directional, set our alpha at 0.05, and this time the degrees of freedom are 7. Because the degrees of freedom for a paired sample t-test are n-1, where n is the number of pairs. So we have 16 puppies divided into 8 pairs, therefore degrees of freedom is 8 minus 1, or 7. So we return to the t-table at the back of our notes. We look up a two-tailed test, alpha equals 0.05 with 7 degrees of freedom, and we find what critical value? Positive negative 2.365. Now we are ready to conduct our paired samples t-test in SPSS. So let's calculate the statistics. We're still using the puppytraining.sav dataset, the one that I set up kind of oddly. Again, you'll see more about that in the next video. Just know that this is not how someone would typically set up a dataset. So in this example, we have a clicker group and a food group. Those are the scores for each of the puppies in those groups. And we're looking right now at variable view. Flip over to data view, and we'll see that the clicker group and the food group are about half as long as the correct and group variables were. In fact, if you look closely, you'll notice that these data are exactly the same. The first 8 data points in the clicker column are the same as the 8 in the correct column. And the remaining 8 from the correct column are the same numbers that are in the food column. So, same data, different test. Let's find out what happens. To do the paired samples t-test, we'll start with our Analyze menu. So go to Analyze, Compare Means, and then Paired Samples t-test. So here we have the paired samples t-test pairing variables. We have a clicker group and a food group. We're going to move those 2 variables into variable 1 and variable 2. Now notice that although that is the first pair, SPSS asks us for the second pair. And if we were to put 2 more variables into the second pair, it would ask for a third and a fourth. It just keeps asking for pairs. So don't feel like because it now wants a second pair that you have to put something in there. It's just giving you the place if you wanted to run multiple paired sample t-tests. We just want to compare clicker to food. There are no options under options or bootstrap that we are interested in. So just click OK and let's see what happens. We see that the mean and the standard deviation for the groups are exactly the same as they were for the independent samples t-test. For the clicker group, the mean is 6.38. For the food group, 5.13. We also see that SPSS has given us a correlation. For now, you can ignore this correlation output. And I will warn you, be careful that you are interpreting your t-test from the paired samples test box, not from the paired sample correlations box. So we could have a significant correlation, but not have a significant t-test. So let's go down to the paired samples test box. Again, no Levine test. We do have means, standard deviations, standard errors. By the way, where do those values come from? These mean, standard deviation, and standard error of the mean are for the paired differences. So this is the mean difference, the standard deviation of the difference, and the standard error of the mean difference. The three boxes that we are most interested right now are the t, degrees of freedom, and the significance value. We would write this up as t with 7 degrees of freedom equals 2.76. I've rounded it up from 2.758. Comma, p equals 0.028. This is a different outcome than what we had with our independent samples t-test. So let's go back to our 5 steps and do the write-up. The t-value was 2.76. But when we make our decision this time, we conclude that clicker training was more effective than traditional food reward training. T with 8 degrees of freedom equals 2.76, comma, probability equals 0.028, a two-tailed test. Now, by the way, how did we know that clicker training was more effective? Because clicker training had the higher mean. We would make mention of the mean and standard deviation for both the clicker and the food reward training groups when we did our full APA write-up.